The universe is filled with mysteries that defy explanation, until now. Look up at the night sky. It seems peaceful and unchanging. Yet beneath that calm, the universe churns with secrets. Phenomena so powerful and strange they strain our current physics. Signals appear that refuse to fit our equations or models. Tonight, we pull back the curtain on cosmic enigmas that linger in the mind. The cosmos is a detective story, and we are the sleuths, piecing clues across billions of light years. Each strange signal is a breadcrumb leading toward a larger truth. Our first mystery is a cosmic ghost, an invisible presence that appears to dominate the universe. We call it dark matter. We can't see or touch it because it emits no light, and it's completely transparent to any form of electromagnetic radiation. It's not built from the familiar particles that form stars or planets, but belongs to a completely different category of substance. So how do we know it's there? We see its influence through the one force it seems to obey: gravity. The evidence is overwhelming. First, stars on the outer edges of galaxies orbit far too fast, defying our laws of gravity unless a huge halo of unseen mass provides the necessary pull. This effect scales up to galaxy clusters, which move so fast they should have flown apart billions of years ago. The fact they haven't implies a vast reservoir of unseen mass acting as cosmic glue. Finally, this mass warps spacetime, bending the light from background galaxies into stunning arcs and rings, a phenomenon called gravitational lensing. When we do the math, the numbers are staggering. On cosmic scales, dark matter outweighs all the normal matter. Every star, planet, and gas cloud combined, by a ratio of about 5 to 1. It provides the invisible scaffolding upon which the entire cosmic structure of the universe grows, guiding galaxies into the vast filaments and clusters we see today. Dark matter is therefore both one of the most robust findings and one of the most frustrating mysteries in modern physics. We know it's there, but we have no idea what it is. About 1,270 light-years away in Cygnus lies KIC 8462852, Tabby's star, named for Tabitha Boyajian, who led the initial study. Slightly bigger and hotter than our Sun, otherwise ordinary, yet it dims in strange, non-periodic ways. Kepler watched 4 years, logging dozens of events, some plunging by 22%. For scale, a Jupiter-sized planet blocks about 1%. Dips last days to weeks with no repeating pattern. It suggests a chaotic swarm intermittently eclipsing the star. Natural ideas came first: interstellar dust or shattered comets, but the blocked light spectrum did not match typical dust perfectly. A last resort notion followed: an alien megastructure, a Dyson swarm harvesting starlight. Intriguing, but only after natural causes are thoroughly tested. New data favors dust or comet swarms, though ambiguity remains. Tabby's star is a lesson in humility, a cosmic what-if that keeps minds open. Imagine pointing a giant radio telescope towards the heavens, tuning the dial across the vast frequencies of the universe. For the most part, you'd hear a gentle cosmic static. This is the cosmic microwave background, the faint residual afterglow of the Big Bang itself, a constant whisper-quiet hiss from the dawn of time. But then, without any warning, for just a few thousandths of a second, an immense and powerful blast of radio waves erupts. This is a fast radio burst, or FRB. For that fleeting instant, it can outshine all the stars in its host galaxy combined. First discovered accidentally in 2007 while reviewing archival data, these enigmatic signals were found to be coming from billions of light-years away. The energy they unleash is staggering. In the blink of an eye, a single FRB can release as much energy as our Sun generates over several days, and yet, whatever creates them must be incredibly compact. The brevity of the flash tells us the source can't be more than a few dozen miles across. Tiny, yet titanically powerful. Early theories focused on cataclysmic, one-off events, like the collision of two neutron stars or a black hole swallowing a star. It seemed the only way to generate such power. Then came the repeaters. Astronomers found an FRB source that flashed again and again, completely changing our understanding. A destructive event couldn't happen twice. This pointed to a new leading suspect: Magnetars. These are city-sized stellar cores with the most ferocious magnetic fields known to exist, trillions of times stronger than Earth's. A starquake on its surface could snap these field lines, releasing a colossal amount of energy. In 2020, this theory gained powerful evidence when we caught a weaker, FRB-like burst from a known magnetar inside our own galaxy. It was the first time we'd seen one so close to home. But the mystery isn't solved. Not all FRBs fit the same mold. Some repeat with a predictable, periodic rhythm. Others flash completely at random. Some are persistent, while others are observed once and then go silent forever. Within the signals themselves, we find intricate, millisecond-long structures we are still working to decode. These details could be a fingerprint of the engine that powers them. While no credible scientist claims aliens, the sheer diversity of these bursts hints that there may be multiple types of sources, or perhaps that they are governed by a new kind of physics we do not yet grasp. They are a cosmic puzzle and a powerful new tool to probe the universe. Across the vast expanse of intergalactic space, something is amiss. A hidden, immense gravitational pull is tugging not just our Milky Way, but our entire local group of galaxies, and countless other galactic neighbors, toward a specific region of the sky. It's a cosmic current, a powerful flow that defies the uniform expansion of the universe, pulling us toward a destination we can't fully see with our own eyes. Astronomers have given this mysterious source a fittingly epic name: the Great Attractor. Our galaxy is hurtling through space at a staggering 1.4 million miles per hour. That's about 630 kilometers every single second, drawn inexorably toward this gravitational anomaly. While the overall expansion of the cosmos accounts for the general motion of galaxies away from each other, it doesn't explain this specific, directed movement. This extra sideways push, what astronomers call a peculiar velocity, is the telltale signature of a massive, unseen concentration of mass pulling us off our expected course. By tracing the direction of this peculiar motion, we can pinpoint the source. The pull originates from a region of space behind the constellations Centaurus and Norma. But looking in that direction presents a major challenge. The dense plane of our own galaxy, thick with gas, dust, and stars, blocks our view. Astronomers aptly call this frustrating cosmic blind spot the zone of avoidance. To solve this puzzle, we must look beyond what our eyes can see. Using wavelengths of light that can pierce through the cosmic fog, like infrared and radio waves, astronomers can finally begin to map this hidden territory. These observations unveiled a colossal structure lurking behind the dust. The Norma Cluster, a city of galaxies containing the mass of thousands of Milky Ways. It's a prime suspect, likely responsible for a significant share of the gravitational pull we feel. But here, the mystery deepens. When scientists calculated the mass of the Norma Cluster and other visible structures, they found it wasn't enough. Even with this massive cluster, our motion isn't fully explained. The numbers still don't add up. This discrepancy forced astronomers to zoom out even further. Larger-scale maps revealed that the Great Attractor itself is being pulled by something even more immense: the Shapley supercluster, the largest concentration of galaxies in our local universe. All of these structures, our galaxy, the Great Attractor, and even parts of Shapley, are gravitationally bound within an even grander cosmic web known as the Laniakea supercluster. Its name, from Hawaiian, means immeasurable heaven, a fitting description for our home basin of cosmic currents. Within this supercluster, we are but a tiny speck in a vast river of galaxies, all drifting along invisible filaments of dark matter toward a vast, shared gravitational basin. The Great Attractor is more than just a destination. It's a profound reminder that our cosmic neighborhood is shaped by hidden structures on scales we are only beginning to comprehend. It shows us that we are part of a dynamic, interconnected system, and we have only just started to chart its incredible depths. These aren't failures of science, they're triumphs, marking the frontier of the unknown. From dark halos and dimming stars to millisecond bursts and cosmic rivers, each riddle fuels discovery. New eyes on the sky will map, pinpoint, and probe, accelerating our path toward truth. Some cherished ideas will fall. Good. That's how science moves forward. When you look up, remember, the darkness isn't empty. It's a canvas for wonder. Our journey has only begun. The greatest discoveries await in space's silent beauty. Comment "Mystery" after 60+ seconds for your free space guide, and subscribe for next week's cosmic revelation.